Okay, so to kick us off, I think what we're going to do is that I just want to run into Canvas real fast, okay? So that we can look at a couple kind of nuts and bolts things. I'm not going to spend like the next hour going over the syllabus, so you all can like collectively exhale for a second, because I know that's like the dreaded part on day one is going through like every single class policy. I'm not going to do that because we're all adults, we're all good, decent human beings. If there's a problem, we will manage that problem as we get there, okay? I'm giving you homework instead, so maybe I'm not the good, decent human being on day one. But I do want to show you a couple things because there is some information that's critical to communicate to you guys on our first moment. So I've just logged into the SEC homepage here real fast. And if you're new to the school, and especially if you're new to online resources at SEC, getting to our digital home away from home, which is called Canvas, is really, really easy. So it's right there in the vertical nav bar on the SEC homepage. It's going to ask you to sign in. What's your W number, or what's your username? I gave you the answer. It's your W number, okay? It's your W number. So please make sure you continue to bring your e-services credentials everywhere with you. I don't know your password. I really, really don't know your password, and there's absolutely nothing I can do to help you other than tell you to hit the gigantic help button, okay? So please don't ask me. Yeah, and it's like, hey, let me Google that for you, okay? So this is your dashboard to Canvas. Now there's a couple things that I'm noticing that people are kind of running into, a couple problems that I've noticed this week. If your class isn't showing up on this list, panic. Don't panic. Actually, don't panic at all. It's actually not a problem at all because there's one of two things that are going on. A, you are not physically enrolled in the class yet, so you're either on the wait list. If your instructor gave you that ad number like right now, the databases don't update until midnight every single night, so you won't get access until the next day. So don't panic. It's not an indication that you're not enrolled in this class. If you know you're enrolled, like for example, if I called your name on our official rosters here, okay, and you don't see our Canvas shell inside your dashboard, here's one little power user trick, okay? So it's this button right here. This is going to pop out your courses shelf. And way down at the bottom, these are all the courses that I have favorited, okay? Way down at the bottom, there's a button here called All Courses. Now, why I bring this to your attention is because this is going to show you every single course that you are participating in Canvas. The ones that are starred are going to show up on your dashboard, okay? And only the ones that are starred are going to show up on your dashboard, okay? So if you don't see us on, the introduction to 3D modeling inside of the dashboard, come here, click the little star, make it orange, and poof, it should show up in your dashboard, okay?
Or it could be like last semester where Pat forgot to make it publicly available.
That's true. That was on me last semester. Okay, so
It's quite funny because it was both classes.
yeah. All right, so welcome to our Home Away from Home. This is going to be our digital hub for all things 3D modeling in this class. 100% of your learning resources and our kind of administration of this class is going to happen through Canvas. So definitely make sure you bookmark the site and keep coming back to it over and over and over again. This is where you're going to submit all your homework, get your feedback, get your grades. This is where you're going to watch more videos of me. Sorry, you get to listen to me for a couple hours each week, and then you get to go home and listen to me see more. Yeah. You're going to be hopefully not dreaming of me, okay? You're going to see a lot of me and hear a lot of me. Point being, this is going to be a major, major tenet for our class, so remember this. Come back to it. If we travel over into the modules section, this is where we're going to find all of our weekly content, and I've activated the week 1 stuff. And just very quickly, let's just check out a couple of details of our syllabus, okay? It's a PDF. Please make sure you download it or know that it's always going to be on Canvas for the entirety of its life. I want to start just at the top here, okay? This is going to be a long course. 3D modeling is not an easy craft and an easy art form to learn. It's going to take a lot of energy, a lot of focus, and a lot of patience, okay? Probably the biggest challenge that all of us have is our expectation of what it is that we're trying to do, right? Many of us, myself included, want to hit the ground running and make, Star Wars in 2 weeks. That's not possible, right? That's just not going to happen. This is a very, very, very long journey. Point being, you're going to have a question. You're going to need to reach out to me in one way or another. here's all of my contact information. Please make sure that my email address goes in your address book. That way you don't accidentally miss anything. Canvas is going to automate a lot of communication between you and me, and I want to make sure that stuff lands in your inbox, okay? Those are my office hours. Congratulations. Every single one of you guys have walked by my office. It's literally, poof, right there. That's me, okay? Literally on the other side of those windows is where I hang out, right? So these are the times during the week that I'm going to be in my office. I'm a full-time teacher. This is my exclusive gig right now, okay? So my availability outside of my office hours is kind of none because I'm in here the rest of the time. I really am. I'm either in my office or I'm here. I have a very wonderful family that dominates my after work time. So, getting access to me outside of my office hours is going to be a little bit slim, okay? But there's a lot of opportunities. Tuesdays are really the only day that's kind of a challenge for me because I teach 2 classes back to back. So 8:30 to 9 o'clock in the morning on Tuesdays. And then Wednesday, Thursday, Fridays, I have huge chunks of my mornings available for you guys. So come find me. I'm here. The problem and the probably most uncomfortable thing for Tuesdays or for Wednesdays, Thursdays, and Fridays is that there's going to be a class in this room during my office hours, right? So you're going to feel uncomfortable and strange, like walking into someone else's class and then coming right over into my office. Please try to squash those feelings. It's totally cool. The professors are awesome, right? Whoever designed this building did a really bad job because there should be an exterior door to my office that allows people to come in and out without having to disrupt a class that's currently in here. So we'll just have to manage. We'll just have to manage, right? We will be quiet and respectful. We will. Okay? So that's my office phone number, okay? So if you need to get a hold of me, give me a call. Or email is definitely the fastest way of getting a hold of me. I'll be honest, the chances of me picking up a phone outside of my office hours is 0, okay? Because I'm not, I'm in here the rest of the time. I'm not going to run over into my office and answer my phone during class, okay? However, if you do call and I don't pick up, leave a message. Please leave a voicemail. We have a really neat phone system here at SEC that digitizes your voicemails and sends an MP3 of your voicemail to my email, right? So I'm always going to get your voicemail, even at 2 a.m. in the middle of the night when I know, it's weird, right? But it's pretty neat. It's pretty neat. It's pretty, and it works very, very well. So please leave a voicemail. An email is definitely the fastest way of getting a hold of me, okay? Oftentimes, the questions that you ask during email are things that I can answer in 5 or 10 minutes. And during breaks, like I did just a second ago, I'll check my email. And if it's something that I can answer real quick, I will, okay? So you're likely to get a faster response through email. Questions on how to get a hold of me? Awesome. So for this class, we're going to be spending our Thursday afternoons together for the next 16 weeks. This class is going to run from 1 to 4:30 every single Thursday afternoon, okay? So please make sure you plan your entire life around that gigantic block of time, okay? Yeah, it's huge, okay? We have a lecture component and a lab component, and we also have a TBA lab, okay? When you signed up for this class and many other classes on campus, there's that TBA, that third section is something that tends to be a mystery to some folks. Let's just chat about it for 1 second. Does anyone know what the details of the TBA lab are?
I was expected to be put in outside of class.
Bingo, bingo. To get a 3-unit class or to achieve 3 units in the state of California, I'm required by law to provide you guys with 36 hours of lecture material. Now, if you take from 1 to 250 every Thursday afternoon, times it by 16, bam, 36 hours. Just gave myself a high five. Did what I'm supposed to do right off the gate, right? However, or in addition, I'm also required to give you 54 hours of lab time, right? And again, if you were to just do from 3 to 4:30, times that by 16, we're only getting to about 27 hours of lab time. So you have to do an additional 27 hours of lab time outside of this class over the next 16 weeks. What that translates into is about 90 minutes of outside of class time work that you're expected to do every single week down over in the design lab, okay? For us in the 3D world, this is not a problem for us because it really isn't. Ain't nothing we can do in 90 minutes, right? Every single homework, every single lab assignment is going to take longer than 3 hours, basically, okay? This week is probably the only exception because it's week 1, but our art form takes a tremendous amount of time, okay? the guys and gals at Pixar or Industrial Light and Magic or some of these big game studios, they make this look incredibly easy, but the good honest truth is that it's not, okay? It just, the number of hours is immense, okay? I literally just finished a project right before we wrapped up for the holiday break, and I easily put 60 or 70 hours into one model, okay? 60 or 70 hours into one model, okay? This stuff takes a while. Yeah. Okay, so like I said, Cody's been with me almost since the beginning of my career here. I have a project that is unfinished, right? And Cody likes to remind me that it's unfinished, and I'm cool with that. It's a labor of love. It's literally the first semester that I started teaching, or the first year that I started teaching, I discovered that I had a winter break. This is the first time where I had a winter break, and I was like, I have like 5 weeks to do nothing right now. My wife actually at my time, she was my fiance, she was off working, and I was like, what am I going to do for 5 weeks on my own? I have nothing to do for the entire, during the holiday break. So I was like, I want to make me a 3D model. Being a 3D modeler, of course, that's what I did. And I have made and am still in the process of making a one-to-one recreation of the HMS Victory, which is the British flagship of the British Navy, right around the War of 1812 time period. And it's pretty intense. Me being me, it's both the outside and the inside, and it's a full 3D modeling. It's crazy, but it's not done. And it will never be done. Well, you were reading my mind. It will never be done because that's a Moto project file, and now we've moved on. So pretty much. It's an intense model.
The nails are going.
Well, yeah. Point being, our work just takes some time. Okay. I'm wholesale jealous of my colleagues in the graphic design and web design industry at this school, right? Because they can spend, 5 or 6 hours on a project and they're done, right? They can go from concept to completion in 5 or 6 hours. There's nothing we can do in 5 or 6 hours. You are blocking your model out at the conclusion of hour number 5 or hour number 6. This stuff just takes a while to do, right? So lean into that idea that you're going to be spending some time on these projects. Cody works over in the lab, so he's aware of this, but at the end of every semester, we do kind of a report on how many hours each class logs over in the design lab. And there's kind of like this little, very unofficial, informal contest between all the full-time professors as to whose class gets the most lab hours every single semester. And I think we've stopped doing it because it's just no longer a competition, because GCOM 402 is my cash cow, right? You guys, by a magnitude, spend more lab hours than any other class combined, which is kind of crazy. I think number 2 last semester, was GCOM 330, which is our digital imaging class, our Photoshop class, right? And I think they had 4 different sections, and I added up that total lab hours for all 4 of those sections, and still my one section of GCOM 402 had more lab hours than 4 330 sections combined. So you guys are going to be spending a lot of time in the design lab working on this stuff. Yeah? No. we win respect points, all right? No. I wish we won something.
Measured how many pitying glances are thrown your way in the lab as you are toiling away.
You got it.
And
okay.
You cannot, I am planning on downloading Maya on my desktop.
Mm-hmm.
I still need to log in lab hours, or are those included?
Yeah, so right now we don't, and that's a good question. So what Mr. Olson was asking is that he's planning to do some of his lab time and his homework time at home on his home PC or Mac, which is awesome. I think that's a really great thing. We can't track those hours.
So I still have to come in and log.
You still have to come in and log some hours in. Now this is a cumulative kind of score for us, right? So you could do all 27 hours in May, right? Or you could do all 27 hours next week, okay? What we report back to the state is the total class hours. So let's say Seth, not that you would only spend 2 hours in the lab over the next 16 weeks. Yeah, this is not going to happen because I know it's not going to happen from last semester. Let's just pretend that he does 2 hours and Tony does, 50 hours. Congratulations, Tony just gave, did all the required lab hours for Seth, right? So we report the class, not each individual student's contributions. I'm probably not going to emphasize this again because, like I said, for this class, it's not a problem. Like, it has not been a problem. There are some classes on our campus where it's a problem, where folks are not doing the required lab time over in the design lab. But for my guys and gals in the 3D modeling and animation, it's a non-issue for us, which is pretty cool. Real quick, I want you guys just to be aware of the outcomes of this class, because I think it's really important that on day one that everyone at least just kind of hear in his cognitive of what it is that I'm trying to get you guys towards, right? I'm going to be directing you towards all of these outcomes, and some outcomes we're going to hit pretty early, some it's going to be May before we really can say that we're masters at them. But these are the outcomes of this class. We're going to be looking at traditional 3D modeling in here. So this is not a trick. This is not like, you know, the 3D models that you make in Illustrator. You know, these are true polygonal shapes that can be seen and rotated in 3D. So think Pixar. Okay? Think of the art assets that you'd see in a video game. Those are the types of models that we're striving to create in this class. We're using all the best industry software, so we're not using stuff that no one's ever heard of before. The entire world that we live in is thrust into that professional realm. Okay? In addition to looking at both hard surfaced and soft surface objects in this class, we're also going to be talking a lot about rendering and texturing, which is a big part of our workflow. I like to think that as 3D modelers, we have a whole series of different hats that we have to wear. Some days we kind of put like a little construction worker hat on, right, a little hard hat, and we're physically building skyscrapers and stuff, right? Other days, like we take off the hard hat, and we put on like a French beret, and now we're going to be painters, right? And that's just what came to my mind, okay? Another day, we'll take off the beret, and we'll put on our cinematographer or our photographer hat, because, you know, fundamentally, if you really take a step back and look at it, we're not in the business of 3D, we're actually in the business of 2D in this world. We create 3D models in these wonderful environments, but at the end of the day, what our audience is going to exclusively see is a two-dimensional photograph or two-dimensional film of our three-dimensional shapes, okay? So we're going to be looking at a couple important ideas and a couple different, or we're looking at this art and craft through a couple different lenses as we go through this semester, okay? Another thing that we're going to be looking at is how to prepare and create our models for animation. We just can't do whatever the hell that we want to do when it comes to 3D modeling. There is an expectation that we're building models to be animated, right? If you take a step back and look at the responsibility that a 3D modeler has, it's pretty immense, in all honesty. Whenever there are three basic phases, okay, of an animation, okay, three gigantic kind of time periods. And this could be the same for a traditional live-action feature film as well, right? Does anyone know the 3 stages of production for a film? You probably know it or have heard of it. You got it. Pre-production, production, and post-production, right? And the same thing. It's very easy. It's very easy. So easy, it's hard, right? You know, for us in the animation world, we go through that exact same process, right? I kind of take the perspective that we are production artists in this class. All the concept work has been done. Someone has handed us the concept drawings, and now it's our responsibility to fundamentally make that thing, right? There are very few opportunities in this world for concept drawers, right? It's actually kind of, a lot of folks get into the idea they're going to be a concept artist, and then the reality of it is that there's not too many openings as concept artists. So most folks end up as production artists, someone like me, who's fundamentally responsible for building the art assets that you see on the screen itself, right? When we get into the production world, once all the concept guys and gals do all their design work and they hand us all their drawings and all their schematics to us, it's our responsibility as 3D modelers to build all of these assets. We're the first crew that's hired for a show, okay, for when it gets to that production phase, okay? Because you can't animate something until the model's made. You can't place a camera in a set until the set by the modeler has been made. You can't rig something until the model's been made. You can't texture something until the model is made, right? Everything begins with the 3D modeler, right? We kind of set the entire foundation for pretty much the remainder of the show or the film or the video game that we're working on. It's a big responsibility that I take very seriously, okay? There are many ways of getting to our end results, okay? But there are some massive pitfalls and some landmines that's fundamentally going to stop us in our tracks. So I'm going to show you some legit techniques and kind of the right way to create 3D models so that they can be animatable, so that a texture artist can create UVs and paint on top of them, right? You know, the worst moments out there in production is when someone later on in the production cycle returns your file and says, I can't work with this, right? Which happens, okay? So I'm going to be showing you kind of the process or the outcome of the process that we're on to ensure that our models are compliant and that will work in the rest of the system that we're kind of working within. Yeah?
So we have Maya and Modo. Which one are we?
Hang on to that thought just 1 second. We'll come right back to it, okay? How many of you guys saw Into the Spider-Verse over the holiday break? I did, and it is amazing, okay?
I'm watching it tonight.
I'm not going to say any spoiler because it's very, very good. It's very, very good. It's a special film that took myself and many others by surprise. You don't make a film like that at that complexity because it's a dense film, right? And I think that was one of the things that surprised me the most was the visual complexity and density of every single shot in the film. 3D animation in video games are not solo endeavors. You cannot do this by yourself. You are working on crews of hundreds of artists and animators to get to that end result. I hung around because I was curious, and you know I'm kind of in this world. I hung around and I watched all the credits, and I was blown away at how many people were involved in Into the Spider-Verse. As just a comparison, how many folks do you think are involved in like an average Pixar film? Production crew. Not like the managers and the producers and things like that, but the actual artists and animators. Say again?
150?
More than 100 and 150.
Like 300?
Yeah, it's about 400 people that are involved on a show, okay? So we don't do these things in vacuums. You can't do an animation by yourself, right? As 3D modelers, there are always going to be artists that come after us that are going to be using the things that we create. So we've got to make sure that what we're building is built correctly so that it can integrate into the rest of the production pipeline. I guess I'm both the right person and maybe the wrong person to be teaching this class, right? So you guys ever see the film Kill Bill? Yeah, with Pai Mei, the old kung fu master, right, with the great little beard thing. I'm like Pai Mei, right? You will do push-ups until I'm tired type guy, right? You know?
He's not lying.
Anyways, there are some legit techniques and some considerations that we need to honor to ensure that what we are making is usable, right? Because the last thing we want to make is put 40 hours into a model and then to have the rigger come by and say, I can't make a skeleton, I can't rig the character, you need to fix this, right? That's a bad day. Okay. One of the other things that we're going to do is that we're going to look at the rendering process pretty intensely in this class, and it's something that we're going to chip away at, and then we're going to do a couple deep dives as we get closer to the end of the semester. One of the challenges that we have is this kind of swapping of different hats as we go through our kind of exposure to this larger production process, and rendering is going to be a challenge. It's probably the most difficult part of our entire process. Our models only live in these little silver boxes. They don't exist anywhere else. So we have to produce some sort of imagery that gets them out of this silver box and into a format that can be put into a film, printed out on a poster, go into an animation or on Facebook or in a video game. This rendering process is the entire big sequential step where the computer takes over and physically draws a picture for us. Okay? And it's intense. It really is. There's a lot of technology. You're going to find that 3D modeling and animation requires a more technical artist than we find in other industries. Even more so now that we've jumped over into the Autodesk, kind of family. Okay, so be prepared to get real technical at times. There's actually a discipline in of just mouse usage, and you're going to see that you have to be a disciplined mouse user in order to be a good 3D modeler, because at times we're going to have to be clicking on something that is exactly 1 pixel by 1 pixel in order for us to select a vertice, for example, right? So lean into it. There is going to be some technology that we're going to have to get good at, okay? But we're going to chip away at it, baby steps. This is an intro level class, and I've been teaching this class for 11 years here at SCC. So I have a kind of a process that we go through to ensure that you guys don't drown, right? At times, I like dropping into the deep end, right, and see how well you can swim. Other times, we're just going to be like kiddie pool, where we just kind of slowly walk in, and then I pick you up and throw you into the deep end and say, hope it goes well. No, I'm joking. I don't do that. When I do drop you into the deep end, you know, I'm in a life raft paddling next to you, and if I fundamentally feel, let me put it this way, I like that you guys taste water every once in a while in the swimming pool, metaphorical swimming pool. I think you learn a whole lot more about swimming when you suck down a couple big gulps of water, okay? But if you're truly drowning, then I grab you and I pull you out, and you know, everything will be fine. All right. That got a little morbid. It was fun? Okay. There's no textbook for this class, okay? All the learning resources that we're going to be using are free online. You're going to get a bunch of stuff from me. One of the resources that I know you guys are going to take big advantage of are the live streams. I'm live streaming right now to YouTube, okay? One of the cool things that I try to do for you guys is live stream every single class time. There are going to be portions of this entire sequence. Yeah, you can just hear my voice and you'll see my computer screen. Sebastian's looking for a camera, so no cameras. There are going to be portions of this class where we have to follow a 200-step sequence. And if you get out of sequence by one step, it's just not going to work, right? It's impossible for both me and you to kind of reproduce all of that. And our stuff is so visual that the live streams become a critical moment for us in the learning process. So I'm going to be live streaming to YouTube every single week. I'm doing it right now. That's why I got all my gear up here, okay? At the conclusion of our live streams, the moment I hit stop, as you guys are walking out the door, YouTube is awesome, right? Because it automatically archives and keeps the live stream on my YouTube channel. So we watched a video at the beginning of the class. If you go back to my YouTube channel, which is uncreatively titled, let's just look at it real fast since we're on the subject. Okay. All right, so if you go to YouTube and do a search for my YouTube channel, which is uncreatively named Pat Crandley, okay? I don't have one of those weird channel names, okay? There I am. This is me, okay? You see right now, we're live on the internets, okay? I would encourage you to subscribe, but actually I'm not encouraging you to subscribe, because I live stream all of my classes, and you will get a notification from YouTube every time I start to live stream. So you'll get something almost every day that says Pat's live streaming in 10 minutes or something to that regard. So if you don't want to get spammed, or you know, you probably can turn all those notifications off, but subscribe if you'd like. Just be aware of it. It's always going to be a resource for you. Yeah.
Have you thought about utilizing playlists? Is there a separate class?
You know, I have, and for a while, if you actually go into my playlist section, I started to kind of do it, but I walked away from it a while ago because it just takes some time. It just takes some energy. So it's all on there. I don't take anything down, by the way. These are all the live streams from last semester. In every sense, the live streams kind of turn into our digital notes, okay? So please go back, review them. You guys are going to make a connection with what we talk about and see in class. It's good to be able to revisit those and see specifically what it is that we're doing and how we're putting all this stuff together, because I don't like to sugarcoat it. It's complex. It's really complex, or can get complex, okay? Couple things that you're going to need for this class. A flash drive, okay? Got to have some sort of external storage. This is a closed lab. You're only going to be in here in this room on Thursday afternoons from 1 to 4:30. There's a class before, there's a class after you guys this afternoon. This is the only chance that you're going to be in here. So you're going to have some sort of method to take the files that we create in class with you home, okay? A flash drive is great. Cloud storage is even better, in my opinion. I'm a big fan of cloud storage. As part of the bundle of things that you get when you enroll in a California community college, especially here at Los Rios, you get access to your own student Gmail, which is kind of cool, which gives you 15 gigs of a G drive too, which is separate from your normal, kind of personal Gmail if you have Gmail. So that's good cloud storage that I would encourage you to use. It's, man, I do everything on cloud storage these days. I used to cart around 1,000 thumb drives, and now everything's out there in the cloud. So just get something, either a flash drive or utilize the cloud storage that Los Rios provides you, or your own. All right, questions on that? Yes, sir.
Oh, those have questions.
This is a good time to talk about our technology. if you go back to the week 1 module, I've put down here a link to the Autodesk website. Actually, let's do this because this is fun. Some of you guys have been with me for a long, long time. My wife and I have been watching that Tidying Up show on Netflix. Have you guys watched that at all? It's with Marie Kondo, I think her name is, and she like helps you like, you know, organize all your clothes and stuff and tidy up your life. And it's really fascinating, and it's really just a tremendous amount of fun. And one of the things that Marie says, you know, if you're trying to get rid of a lot of stuff, is that when you time to get rid of something, you thank it, right? You say, thank you, t-shirt. You've been with me for 10 years. You don't spark joy in my life anymore, so it's time to go, right? You know, I don't wear you t-shirt anymore. You know, it's time to go. So I'm going to do the same with Modo. Thank you, Modo. This is the software that we just left, by the way. Thank you, Modo. I appreciate your energy and your time with us over the last 10 years. You spark a lot of joy, but it's time to put you in a trash bag on the street. Okay, so goodbye, Modo. We love you very much, but we have fundamentally switched over to a different software platform this semester, one of which that's developed by a company called Autodesk. Okay, Autodesk is probably top 3, maybe top 5 software development application company in the world. Okay, Autodesk is huge. They have an entire like skyscraper down in San Francisco, right? I think someone said they have an entire pier with it. It's really cool. They are a huge mega corporation, right? Every design and engineering firm on the face of the planet uses an Autodesk product, especially if you're in the architectural world, right? Every bridge, every skyscraper, every house building is probably created and designed with either AutoCAD or Revit, right? Those are the flagship products of Autodesk. In addition, for us in the media and entertainment world, they have their flagship product is a piece of software called Maya. And Maya is the old dog. It is the 900-pound gorilla in the 3D modeling and animation world. It is one of the originals, okay? And we're going to be using Maya as our central 3D modeling and animation package going forward. So we said goodbye to the Foundry and hello Autodesk, which is really kind of great, okay? One of the great things about being a partner with Autodesk is that they provide to every student on the face of the planet a free personal copy of their software, which is pretty cool. Okay? The only thing that you need to do to get access to your free personal education license of both Maya and Mudbox from my other class. Oops, I zoomed in too close. What's Mudbox? Mudbox is a sculpting app. Yeah, I encourage you to check it out. My game art class is going to be using Mudbox in a very direct way. But if you go into the menu section here, the upper right-hand corner of their website, students and educators, that's where you're going. Not free trials. This is something different, right? You want to go into the student and educator section, which will take you to the education landing page. And then where you go from here is simply free software. Okay? Follow these instructions, these 4 simple steps, and you'll be good to go, okay? Now for us in the Maya world, we want to make sure that we're downloading the correct version of the application. I think right now you can download probably 6 or 7 years worth of Maya installations from their website. I can't log in at the moment with my personal stuff, but if we were to simply, on this page, click on Maya, okay, sign in with your account, okay, oops. And then, of course, you choose your operating system. It's Mac PC, which is kind of nice. And then you got to choose the version. Okay. Now we are using Maya 2018. Okay, 2018. When we were putting Maya on all these machines right before we broke for the holiday, I remember vividly saying or having a conversation with our computer services guys and gals about 2019, because I was asked like, hey, is Autodesk going to come out with the 2019? I said, yep, they always do every single year. Right around Game Developers Conference, they always come out with 2019. They went, oh, great, so we don't have to worry about it for a couple months, right? And I went, yeah, we don't have to update anytime soon. Fast forward literally a week, and we all got a lovely Christmas present of Maya 2019. And I went, gosh darn it. So we're working on Maya 2018. Please do not download 2019. The files that you create in 2019 are not going to be openable in 2018. Files are very rarely backwards compatible. Okay, so please make sure you download 2018. Okay, and then everything will be just fine. All right, so there's no reason not to download the software and continue to learn it at home. Check out the system specs. You're going to need a pretty good graphics card to run the software. This is pro-level stuff. Every major film studio in the world uses Maya as their central 3D modeling and animation package. So this isn't some like rinky-dink little crew. This is it. This is the big dog, and sometimes the big dog requires a little bit of oomph. Okay? Yeah.
Is it way more taxing than Modo was?
Way more taxing. Yeah, the renderer is very slow. In some things, yeah. Blender has a really amazing series of GPU-based viewports. We have a little bit of that in Maya. The rendering is what is the most taxing for us. And
The rendering was CPU based.
it's all CPU based, yeah. And the interactions that we see in the viewport are going to be GPU based. So, you need a good like little kind of mid-level machine to run, to run these pro-level things. Yeah, if you have like a gaming PC or something, you're fine. Every once in a while, someone asks me, it's like, I got like this $200 netbook from Best Buy. Is that going to work? And it's like, no, that's not going to work.
Try.
Okay.
Put it in a freezer.
Huh?
Put it in a freezer.
Yeah, it will make it melt for sure.
What account do we log into? Do we log in with our
So you're going to sign up for your own personal Autodesk account using your Los Rios email or even your own personal email, and then that's the account that you sign in with.
How do they know we're students?
That's their problem.
They will ask for some specific details, including your student ID, as well as your name and what college you go to, and then they'll verify that you're enrolled.
Yeah, this is the crazy thing about that. They don't actually ask those questions.
Google asks the question when you ask.
Yeah, I'm pretty sure the only question they ask is what school are you a member of right now, and that's it. Yeah, yeah. This is one of the big benefits of participating with a Fortune 500 company, right? Is that they're giving it away for free, which is kind of nice to students. So, okay.
Like, what is it?
They've got so much money they don't care about your subscription.
Yeah.
And this is like, are you making money? And you just have an option like,
Nope, I'm not. You could be, but you're not. Yeah. Loopholes abound for sure. Okay.
I mean, let's be honest, they probably don't care that much about the maybe $1,000 a year that you get from
Yeah.
the personal as opposed to the millions that like ILM probably has on their
That's the
budget
thing.
per year.
That's the thing. If you were to go to the actual Autodesk homepage,
It's
okay,
1,500.
yeah, their software for a commercial license is not inexpensive, right? So if you're Industrial Light and Magic or Pixar and you need 2,000 seats of Maya, that's Autodesk going cha-ching, right? They don't care about you and me, with our student
They're
license.
getting Pixar to animate the money eyeballs.
Exactly,
Yeah.
And
exactly.
they're making sure students learn it.
That's per seat, yeah, per year. I know, right? Yeah, right? You get, look at this. $200 off for AutoCAD right now if you're a professional user. Like, this is the benefit of being a student, right? Because you get access to a lot of software for free.
that's,
Yeah, no, it really is a cha-ching moment, right? It gets pretty expensive. Yeah, especially if you're Autodesk and you've made an arrangement with a huge studio like ILM or Pixar or Sony Pictures. That almost turns into a guaranteed income for their crew, right? Because Pixar is not going to they're not going to shrink in of the number of installs that they're putting on, especially with a big app like Maya. So they can take that as a bank, as they say. All right, so check it out, download it. There's not a reason to not download it. You're going to find that Maya is incredibly deep. Okay, it's been around for like literally probably 25 years. I first started working with version 4 of Maya back in college, and that was 20 years ago for me, right? Over the years, it's been very actively developed, and it's turned into this beast of an app. That's going to require you guys just to kind of tinker and play around with it, okay? I am not an expert in every facet of Maya, although I'm a pretty darn good Maya user. I've been teaching Modo here for the past 8 years, but what I haven't told anyone really is that I also teach at UC Davis, the 3D modeling class done over there. I also teach at the Art Institute and at AI and at UC Davis. It's all Maya stuff for me. So I'm as much of a Maya user as I am a Modo user. So it is a deep thing. It's a very, very deep app. All right, let's get back to it. Let's return to our syllabus just for one moment, and then we'll jump in. I'm pontificating. Okay, there's nothing else that we need in class. Okay. I want you to just kind of go over the syllabus a little bit today on your own time. There's some policies that I want you guys to be at least aware of. There's some grading information that you can definitely check out. It's all pretty clearly established in the syllabus. The one thing that I want to draw focus to just real quickly is the schedule, the calendar, the stuff that's coming up. This is going to give you a pretty good 10,000-yard view of what it is that we're striving to accomplish in this class. And we're going to be taking you through a lot of different projects and puzzles, if you will, that will start helping you understand how to help you understand the art of 3D modeling. So check it out. These are all the big picture items for us. One thing that I think is important to point out is spring break this year is this week, in between this one and that one. It's right smack dab in the middle of April this year, which is wholesale much later than it has been in many other years, which is kind of in the way. I think last year it was the fourth week in March, and this year it's the middle of April. So it's a little bit later, but keep that in mind. Okay? In addition, some other dates that I want you to be mindful of are down here at the bottom. And these are dates that no one talks about on campus, but they're really important, so I want to, at the very least, make sure you're aware of it. I need you to do a good, legit thumbs up, thumbs down soul search over the next couple days, and really be sure that this is the time to take this class in your life. There is an expectation that you spend, probably, in all honesty, what it turns out to be 8 or 9 hours of time outside of class every single week on the homework and the lab assignments that we do in this class, okay? So do a good soul search over the next couple days and look at your personal schedule, okay? This class never lets up, okay? There's never a week where we take a week off. It's always, we stomp on the accelerator the entire 16 weeks, okay? If you know that if your academic load is already stressed, or if you know that you're going to be taken away and pulled away from your academic life for X, Y, and Z, just do some soul searching and make sure that this is the right time to take this class. The stats have shown me that historically you guys are going to pass this class, right? And you can only take this class one time, right? So if you pass the class with, if you get a D through an A, you have passed the class, which is really kind of amazing, right? A D is a passing letter grade in the eyes of our administration, right? So you guys are probably more than likely going to pass this class. I want to make sure you're going to get the best experience and you get the most out of this class, okay? So if the answer to the question is no, I'm not going to be able to have the experience that I want, drop the class, okay? If you drop the class before the first, you get your money back. Woo, right? You guys threw down some cash to be here, right? So we'll make sure that gets back to you, okay? In addition, and this is just kind of all across the campus, you have until the 3rd of February to get enrolled in a class, because on the 4th of February we have Census Day, and Census Day is a statewide, kind of moment where the state goes in and they audit the registers, the enrollment registers for every single community college, and they count the physical students that are in the seats. And then a portion of our funding comes from that count that they get, right? Larger point being, it gets very difficult to add a student after census date. To a certain degree, you're kind of an unfunded student, so our administration really doesn't want to add people after census day. So if you're trying to get into a chem class or an English literature class or even a GCOM class, make sure that you are in a roster by the 3rd. It's not impossible to add people after census day, but now there's a couple more hoops that we have to jump through to get you enrolled in the class, right? Now there are signatures involved, and that always kind of turns into a rigmarole, okay? After the 3rd, but before the 21st, you can drop this class and get a W on your transcripts, okay? But after the 21st of April, so what would be on the 22nd of April, you're getting a letter grade, okay? And you're going to get whatever letter grade your grade book determines, okay? I bring this to your attention because right around April 20th, okay, in that last little moment before the final drop day for a W, it's important that we all look at our grade books and do some math, okay, and figure out how, where we're standing in the class itself, okay. What's the worst letter grade you possibly can receive at a California community college? A D, right? Why? Why is it not an F? Logic would say it probably should be an F because you've failed the class, right? But why is it a D?
You can't retake a D, but it doesn't pass for requirements.
Bingo, right? The only way to retake a class for credit is to either fail it or to get a W, right? It's the only way to retake a class, okay? If you get a D, well, maybe let's rephrase the statement a little bit. What is the passing prerequirement for most classes? A C, right? So if you're trying to go on to the next class in this program, you need to have gotten a C or better in the previous class, right? Well, if you got a D and you can't retake the class, what are you? Screwed. You are up a creek without a paddle, right? Yeah. So the worst letter grade you can earn on campus is a D, okay? Yeah. So right about the 21st of April, you need to do a good double check of your grades and start doing some math and figure out, am I going to get a D? Because it happens every single semester where mathematically someone is going to get a D, and I usually propose the question, do you want a D, right? Because if you want to retake this class and continue on in the program, we need to have a conversation, right? Because sometimes it's in your best interest to take the hit, either to take the W or to take the F, and then have the ability to retake the class in the future, okay? No one talks about that on campus. Our counselors don't do a really great job of kind of bringing that information to light, that a D has larger ramifications on your future kind of trajectory than an F will, right? So keep these dates in mind. This is not the last time you'll hear about these dates. I try to go out of my way to mention this to folks again as we get closer to all of them. All right. I'll let you kind of look through the rest of this on your own. It's pretty boilerplate stuff for the most part, but those are the big tenets of our syllabus. Comments, questions? Everyone's good, feeling it, ready to rock and roll? All right, great. Okie dokie. So let's take a second and jump in. We actually have some things that we need to do today. Okay. In order for us to get to get where we need to go, we're going to start learning how to work with Maya today. You actually have a homework and a lab assignment today, which is a whole lot of fun. So here's what I want you to do. Almost every single one of you guys are sitting in front of the machine. Let's just fire up Maya for a second and say hello. Okay. So Maya is down in your dock. Okay. I'm going to zoom in. Please note that we have two Autodesk products installed on these machines. We have Maya and Mudbox. The icons are very, very similar. Just ensure that you're clicking on the right one. I mean, you're more than welcome to open up Mudbox. It's a whole lot of fun, but it's not what we're going to be learning in this class. Just so everyone has the context, Mudbox is a digital sculpting app. So imagine you have a ball of clay, and you use your stylus to push and pull that ball of clay into a sculpture. It's very cool. GCOM 424 is going to be the primary driver of our exposure to Mudbox. So we're not going to talk about Mudbox at all in this class, but take a look at it. It's pretty neat. And it's free for you guys, so there's no reason not to. Okay? So we're going to look at Maya. Let's go ahead and launch the app. Maya is a beast. Okay? It's a huge, huge app that's been around for a long, long time. So give it some love. Let it launch. It does take a minute or so to kind of initialize. Here we go, okay? Now, just because it's open doesn't mean it's ready to run. Unbeknownst to you, down here in the shelf, this is kind of our access, this part of the interface. This is our access window to the back end. You can see that it's still loading a whole lot of plugins and some architecture, so just give it a minute. I usually don't start even thinking about using Maya until I don't see anything downstairs. Still loading in a whole bunch of stuff. Voila! I think we're ready to rock and roll. Okay. All right, welcome to Maya. To get us started here, let's put something inside of Maya that will help us learn how to work inside of this interface. I imagine our 3D modeling applications kind of like a infinite universe. And we're building sculptures, static or three-dimensional sculptures in this infinite universe. This universe is very difficult to describe with it being empty. I'm going to pull you away from Maya just for 1 second and return to Canvas, because down in the lab section here, I've given you guys 2 project files that I'd like you to download, and then we're going to open up the 3D Axis Overview.zip. Okay? All right, there we go. I'm going to download them real fast myself. We're going to need both of them. And they're just zipped archives. These are models that you're free to keep. All right. Say again? Yes, absolutely. Give me 2 seconds to do that. All right. If you look at the thaw space, it should be in there, Rob. Should be. And if it's not, I can blast them to your desktop. What computer number are you? 15. 15. Let's just do it that way. All right. Should be on your desktop here momentarily. You're welcome. Is there anyone else that doesn't have access to those 2 files? Great. Okay, let's jump back. I've just double-clicked on the 3D Axis Overview.mb. This is the file type for Maya. MB stands for Maya binary file. Okay. If we return to Maya for a second, this is what we have. Okay. So now with this cool little arrow thingamajig in here, we can start to get a better understanding of what our simple little three-dimensional universe is all about. Okay. Working inside of any 3D modeling application is honestly quite similar to stuff that we've seen before. I'm going to ask you to do something very difficult for some of us in here, and that's return to a painful moment in your life, also known as 10th grade geometry. Okay? Everyone loves to hate 10th grade geometry, right? Because that was the class that your teacher forced you to show your work, right? You guys know what I'm talking about? I used to always hate geometry because I knew the answer, but then like, you have to show your work, and I was like, I knew I'm right. So, anyways, in 10th grade geometry, we were plotting points along a 2D Cartesian grid, right? You guys remember that? 2D Cartesian grid? Let's just look at it real fast. This is the part of the live stream that I wish I had a camera out for. See folks see me drawing on the whiteboard. Okay, so 2D Cartesian grid looks very, very similar to this, right? I know you've seen it before. This little thingamajig. Right? Remember this guy? Right? With all the little ruler markers. Bonk, bonk, bonk. And then your instructor would come out and be like, all right, I have this little dot like right here. Define for me the mathematical location of said dot. Right. And how would you do it? How would you do it? That's the answer. Show your work. X and Y, right? You start counting the little ruler markers. You'd figure out like, well, the dot's kind of right over this ruler marker. So along this axis, we know the location, right? What is this horizontal axis here? The x-axis. So this is the x-axis. In 3D modeling, the x-axis is, we're working with the exact same thing. It's the horizontal axis, okay? So we know that the location of this dot is at 2 along the horizontal axis, the x-axis. So the inverse is what's correct for this other one. What's this other one called? The vertical. The y. This is the y-axis, okay? So we can very quickly define the location of this dot by counting the ruler markers on its corresponding axis, right? Well, we're fundamentally doing the exact same thing here in 3D. We are nothing, really 3D modeling is all about plotting points along a whole series of grids. Except this is 3D modeling, right? We have a third axis that we're now having to kind of manage. If x is the horizontal, left and right, and if y is the vertical, up and down, what is the z-axis? Depth. You got it, right? Same idea. Okay. the z-axis. This is the depth axis. So if you think about it, this is the x-axis, left and right. Y-axis is up and down. And then the z-axis is forwards and backwards. Okay? We are plotting points along all three of these axes, okay, and then connecting them to each other. 3D modeling, in all honesty, is all about managing dots, okay, managing vertices inside a three-dimensional space. We get to see all of these axes and start to understand their relationships quite easily in what's called the viewport here in Maya. So I asked you to open up this 3D axis overview project file so that we can start to look and understand what this 3D environment is honestly about. Now, before we start, working in this space, let's create a picture in your imagination real fast. Imagine you are out there in space, right? And you're like an astronaut in one of those really rad little jetpacks that they have. Have you seen those? Have you seen the little jetpacks? Our astronauts literally have jetpacks, by the way, and they're like huge, and they're like psh, psh, outside the space station. When I win the lottery, because I believe in the power of positive thinking, right? Because when I win the lottery, I am buying myself a first-class ticket to the International Space Station, and you better believe I'm going to be tooling around outside one of those jetpacks, right? Okay? So I'm an astronaut in a jetpack. The International Space Station is this cool little 3D model. The International Space Station is not moving, and I know that it's actually moving and it's orbiting space, but just for for this metaphor, it's not moving. It's static, right? It's not going anywhere. Me, as the astronaut in my cool little jetpack, I'm flying around outside of the International Space Station, and my perspective and understanding of this space is represented by what we see here inside the viewport, okay? So our models, until they're animated, okay, and we're not going to do any animating in this class, our models are static. They don't move. We move. Our understanding of this three-dimensional space changes with our location inside of this three-dimensional scene, okay? So how do we move around and kind of witness our sculptures from many different angles? Well, there's some keyboard shortcuts that are going to help you out. In order for us to drive Maya, and this is important as you guys go home and start to look at Maya on your home PCs and Macs, there is a hardcore requirement for Maya, and it's this thing, okay? A 3-button mouse, okay? 3-button mouse is required, okay? About half of the interface works around a clickable 3rd button. So if you're working on a trackpad, it's not going to work, okay? If you're working off a stylus, it's not going to work. You have to have a true 3-button mouse, okay? And you don't have to get fancy. I went into Best Buy the other day because I go through mice pretty quickly because I abuse my mice, so I buy them like once a year. I buy a mouse. I went to Best Buy, and they had like a 12-button mouse at Best Buy. And no, you don't need a 12-button mouse to work Maya. You just need like the cheapy $8.99 Logitech mouse. That's what this is. I think we got these on Amazon for $8.99. And that's all you really need. But it needs to be a clickable 3rd wheel, okay? So with that said, let's explore pretty quickly here how this is going to work. So to perform an orbit, to start to rotate around our viewport like this, we're going to hold down the Option key and left mouse button and drag. This is called orbiting. It's a fancy word for rotate, okay? We're orbiting around our 3D model. Option left mouse button and drag. To perform what's called a pan, where we move left and right and up and down, this is Option middle mouse button and drag, okay? Option middle mouse button and drag. So we have orbit, which is left mouse button and the Option key. The pan, which is Option middle mouse button. And as one might imagine, Option right mouse button is zoom in, zoom out, okay? Everyone just take a minute or so and start to throw down this muscle memory. You're going to find that 3D modeling requires a tremendous amount of muscle memory. We're going to be like LeBron James here, okay? Not like actually like LeBron James, because I wish I was LeBron James. He's got an awesome beard, right? I can't have an awesome beard. You just gotta wait, right? I'm too impatient, right? But do you think that LeBron James is thinking about like dribbling the basketball as he's running down the court? No, he's not thinking about that, right? We don't want to have to think about our viewport navigation, so put the time in and create the muscle memory, okay? Okay, so one of the things that we can do inside of our three-dimensional universe here is that we can get as close as we want to our model. Okay, we can get all up in there, as they say, right, and look at very small details right in the middle of the viewport. Inversely, we also can get very, very, very far away. Now, kind of returning to that space metaphor, I'm on like Pluto or something, looking back at Earth. Where is the space station? I don't know, right? Here's the lifesaver, the F key. F for frame or fit. It's going to fit all the objects in your scene inside the viewport. So if you lose your model or you don't understand where we are, hit the F key. You'll return home, or it'll fit the contents of your scene in the viewport.
What's the difference between F and A? If
Uh,
it's A and it does the same thing, is it something else?
I don't know.
Okay.
I don't know. Okay. And we're going to come back to that here in a minute. Yep. So now that we're kind of back home, if you will, let's talk about the roles of these 3D axes inside of our three-dimensional space, because we have a little bit of comfort now cruising around. Okay. Let's take a look at what each one of these 3D axes are allowing us to do. Okay. I've color-coded these 3D axes for you specifically. In our world of 3D modeling and animation, we have standardized around very little, but one of the things that we have standardized around are the colors that represent the X, the Y, and the Z axes. X is always going to be represented by red. The up and down, the vertical axis is always going to be that color green, and the depth axis, the Z axis, is going to be blue. So get used to seeing red, green, and blue often. Okay? Since we can orbit around our three-dimensional scene and take a look at our model from any number of angles, how can we communicate back to Houston, if we're an astronaut, some landmarks? How can we talk about what's up and what's down, right? On planet Earth, talking about up and down, that's wicked easy, right? What tells you up and down? Gravity, right? And more specifically, the inner ear tells you what's up and down. You almost know quickly and instantly when you're flipped upside down, when you're swimming, right? Because the inner ear loses track of the horizon line, the pressures are different, and instinctually you know when you're swimming, I'm upside down. But if you're in space and you have no horizon line and there is no change in pressure on the inside of your ear, how do you tell Houston that I have turned upside down and now the control panel is backwards? How do you do that? How do you, in a world where there are no visual landmarks, how do we keep our bearings, right? Challenge for us, huge challenge for us. Let's put it a little bit more firmly in the eyes of 3D modeling. As a 3D modeler, we have to model our objects in specific directions because we have an entire crew of guys and gals coming after us that are going to be using our 3D models for their works. The animators are going to be using our 3D modelers. The texture artists are going to be using our models. The cinematographers and the set layout guys and gals are going to be using our models. We need to model them in a way that matches some understood, kind of landmarks and bearings. For example, when we model characters, we model our characters in something that looks like this. This is called the T-pose, okay? It is a character with its appendages at an extreme, right? Because it's a whole lot easier to model a character like this versus the classic football stance. That's pretty difficult, right? To model something posed like that, right? So we model our characters like this, and then after the fact, we go in and pose them later, right? So when we're modeling our characters like this, our character riggers are expecting a couple things to be in a very couple defined locations. If I was to take an arrow and put it in the top of my head, what direction is that arrow supposed to be facing? Sorry, I misspoke. And you're right. According to what I just said, it would be pointing down if you stuck it in the head. But the stick coming out of the top of my head would be facing which direction? Up. In a world without any landmarks, in a world without a horizon line, what in the world is up? How do we define down? The nose of our characters, when we model them, need to be facing the front of the scene. What is the front? Yeah, how do we know what is up, down, left, right, forward, and backwards, right? There's nothing in this world that says I'm looking towards the rear of my scene, but I know that I'm looking towards the rear of my scene. once again, it all returns to our Cartesian grid. Okay? This is the science portion of the day, right? You guys ever watch the show Mythbusters? I love Mythbusters, right? Because any show where they like blow stuff up, I'm like, you've got me in the door, right? Blowing stuff up for science. That's really what they should have called Mythbusters, blowing stuff up for science, right? I remember when that show was on, they had a big advertisement online for folks to donate their cars for Mythbusters. Yeah. And they're like, hey, if you want to see your car get completely destroyed on Mythbusters, here's the phone number to call. Okay. I'm going to erase the z-axis just for clarity here. Okay. Now earlier we were plotting some points on our Cartesian grid, but let's actually put some numbers down on them. Now you guys went 2, 2 here. Okay. Which direction on the x-axis represents all the positive values? Yeah, this quadrant over here. So this is, in fact, 1, 2, 3, so on and so forth, right? On the other side of the x-axis, what do the numbers look like? Negative. So this would be -1, -2, and -3. For the y-axis, where's the positive side? Top, negative sides on the bottom, right? Now, which brings up an interesting question. What in the world is this thing? Yeah, the center, the intersection of all three of our axes is 0. 0, 0, 0. This has a very specific and special and critically important name for us as 3D modelers. What is it? The origin, okay? This, the origin, is the center of our universe. It is the sun of our solar system. Our entire 3D modeling world revolves around the origin of our grid. It is the one consistent spot of our three-dimensional universe. It doesn't matter if you're working in Maya, or in 3D Studio Max, or in Mudbox, or in Modo, or Cinema 4D. Every single application understands the location of the origin, the center point, okay? Since this is the one common denominator between all three-dimensional project files, it's where we're going to place all of our content, okay? The rest of our production team is relying that is relying that the 3D modelers are modeling their stuff at the origin of the scene, okay? And we also get some benefits, some efficiencies at modeling at the origin of the scene as well. So with the origin defined and an understanding that our Cartesian grid is really broken up into a whole series of quadrants, we can now start defining some really important landmarks, okay? For us, the positive values along the y-axis do a really great job of defining up and down, okay? If we're plotting points up here in the positive quadrant of the y-axis, this is up, okay? So inversely, if I'm plotting points down here, what's this? This is the negative value, so this is down, okay? This is down. Now, I don't have the z-axis on here, so we'll do y positive equals up. That's part of our vocab, our common vernacular, if you will. And then z positive, what's this? Bingo. It's the front or forwards, okay? This is the front of our scene, okay? If we return back over here to Maya for a second and look at how our 3D axes are kind of laid out, we can very quickly begin to understand where's up and where's down, okay? Remember, you're an astronaut in space, tumbling. How do we communicate back to mission control? Up and down, right? Right now, if you look at the screen, where's up? Up. The big green arrow is pointing up. That is the top or the sky of our environment, if you will, okay? Right now, where's the front facing? Yeah. This way, okay? Understanding these two important landmarks gives us a reference point, because now we can communicate pretty quickly to someone else where we are, okay? Especially if we do this. Okay. With an understanding of up and down, I'm like Sandra Bullock in that movie Gravity. Have you ever seen the movie Gravity? It's an amazing film. It really is quite spectacular. And spoiler alert, you see this in the trailer. She like tumbles out of control in space, right? So Sandra Bullock is now tumbled upside down. And where is up? Down, right? It's the bottom part of the screen. And the front of our universe is pointing away from us right now. Okay? These landmarks help us keep our bearings. They help us understand the spatial relationships between all the different parts and pieces inside of our scene. Now, when we're working on a complex 3D model like a train or an airplane or a character, we're not going to have these big gigantic arrows chilling in our scene. But the developers down at Autodesk have done us a solid, and they've given us this. It's a miniaturized version of my big, gigantic 3D arrows. Okay. Does anyone know what this is called? It's really quite appropriate. It's a compass. This is our 3D compass. Okay. It helps us keep our bearings. It helps us keep track of where up is and where front is. And then the X values, that's kind of arbitrary. Like left and right is kind of arbitrary if you think about it, right? We only really need to define up and front, and left and right kind of takes care of itself, right? It's that third axis that can be very quickly solved and assumed, right? And you have to ask the big question, is it my left or is it Andrew's left, right? So it's kind of an arbitrary idea, okay? We don't necessarily need to draw focus to it when defining our bearings. 2 out of the 3 will get the third one assumed as well. Does that make sense? Yeah? Okay, cool. All right, now that we're a little bit more comfortable, one thing real fast, and I apologize for escaping. The guys and gals down at Autodesk have done a wonderful service, or done us a wonderful service, and they've described the origin of our scene quite directly. How does it look? An intersection. You see those 2 dark gray lines on your grid? The intersection of those 2 gray lines is the center of our scene. That's the origin. That's 0, 0, 0. Okay? So we get a nice visualization of that as well as the orientation of all of our 3D axes. Okay? Okie dokie. So with that said, let's start playing around with the objects inside of our scene. I'm going to say goodbye to this one, and I'm going to open up the teapot project file that I provided you guys on Canvas. Good old teapot. It's been around for a long time. We like it, the teapot. If you haven't downloaded this is in the week 1 module in the lab section. Okay? This teapot is an icon of the 3D industry. Congratulations, you're now participants of the 3D modeling and animation industry. This is an icon of our industry. It really is, and the teapot's an icon of our industry, not because we all like having tea at 4 p.m. or 5 p.m. every afternoon, although that is lovely, and one for a nice cup of tea in the afternoons. The teapot is an icon of our industry because there are some active developers of our world. How long have we been doing 3D modeling and animation? This is today's history lesson. A few decades? Yep. If we were to put a date to it, when did this whole show start? It's a little bit later than the 60s. The 70s. Okay. In the early to mid 70s is when the computer graphics kind of era began. Okay. A lot of folks put it much later than that in their kind of cultural connection to computer graphics, right? But the real research that drove the creation of this entire industry began in the mid 70s, and one of the leaders of that kind of revolution is a guy named Ed Catmull. Okay, and Ed Catmull is kind of the granddaddy of the computer graphics world. He was a researcher at the University of Oregon. And he did an entire PhD and a whole series of postgraduate work on computer graphics and the creation of many of the theories and the algorithms and structures that we use to this very day. And what was one of the first 3D models that he made? His own teapot. And so that's why this is the University of, I said Oregon earlier, I apologize. This is the University of Utah teapot that Ed Catmull made a long, long time ago in a galaxy far, far away. Ed's still around. Everyone thinks that Ed is dead because people in history are usually dead, but Ed is definitely not dead. He is alive and kicking. Does anyone know what Ed's doing now? He is the co-founder of Pixar. Yeah. He's one of the 3 founding members of Pixar. He still works as the president of Pixar to this very day. Does anyone know who the other 2 co-founding members of Pixar are? Yeah, John Lasseter and Steve Jobs. If you look at their roles inside of the early days of Pixar, Ed Catmull was the computer scientist who created the computer graphics. John Lasseter was the animator that brought all these computer graphics to life. And simply put, Steve Jobs, he was the money. Yeah, he was the financier of this whole thing. Does anyone know who Steve Jobs purchased Pixar from? Another little moment of computer graphics history. Yeah, it was one George Lucas. Yep. Yeah, George Lucas kind of data mined all the technology that he wanted from his computer graphics group in the early 80s, and he made a very quick determination that he wasn't really interested in that time making computer animated films. All he wanted was the ability to do computer animation for his live action films, okay? And then the research group at Lucasfilm got so expensive that George went, yeah, I've got what I want in my investment. I want to get out, and he sold it to Steve Jobs, who said, you know what, I think there's a future in computer graphics. I think people are fundamentally going to want to watch a computer animated film, and the rest was history. Yeah. There's a really great book that Ed Catmull wrote called Creativity, Inc., and it is a kind of like a memoir to a certain degree. It's really all about how to lead a creative workforce, and of course his entire perspective is from Pixar, so it's also kind of a history of Pixar as well. I highly recommend it. It's a really fun, easy read, and you're going to learn a whole lot about how to work with creative folks. It's pretty cool. Anyways, back to our computer graphics, right? So here we have our little teapot. Of course, we can continue using our viewport navigation commands to check it out. It's an awesome little teapot, okay? But I want to start doing something with this teapot. Looking at computer graphics is one thing, but we're not going to be, just observers. We're going to be active participants in the creation of these models. So the one thing that we need to do is to be able to select our models, to be able to go in and begin to manipulate them, to change their location, to rotate and move and scale them around inside of 3D. So let's learn how to do that, okay? The first thing that we need to do is that we need to ensure that we're in the modeling toolkit, this thing over here. So I'm on the right-hand side of my interface, okay? If you don't see something that looks like this, hit the tool hammer button right here, right above it. That's going to pop open what's called the modeling toolkit, okay? And the modeling toolkit, as one might imagine, is really the home to all the Rockstar, all-star tools inside the 3D modeling tool set here in Maya. And we're going to start with this top row, okay? Because this allows us very directly to select different components inside of a hierarchy, okay? 3D modeling in the larger animation system is really a manipulation of hierarchies. Now, what in the world is a hierarchy? I love it, yeah. A tier of different things, right? Absolutely. So this would be like if we were like medieval Europe, who would be at the top of the tier of the social system in medieval Europe? Like a king, right? So you're very true. So like the king, and then I'm sure, let's just lords, royalty, right? And then I'm sure let's just do like, I don't know, knights. I'm literally making this up, by the way. And the knights have like squires that report to them, and then eventually you get down to like, the serfs that are in the fields, Huh? Yeah, right. So this is a hierarchy, right? Okay? The king commands all of this stuff, but the squire way down here still has a certain degree of control and independence from the rest of the hierarchy, okay? 3D modeling is very similar to this. We are working with a whole series of hierarchies. The king, if you will, of our world inside of Maya, the top level member of our hierarchy, or the top member of our tier system, is called an object, okay? Everything in our world is an object first. Okay? Now, depending on which type of object we're working with, there can be a whole series of components that are associated with them, right? So in the context of 3D modeling, we have a whole series of components associated with an object. So we have surfaces, then we have edges, and last but not least, we have the lowly vertice, which is, in fact, just a point. It's a dot in space. So, yes, they call them faces. I'm going to call them surfaces because there are a number of different face types that we're going to be looking at. Okay? So everything's an object, but 3D models are really comprised up of a whole series of faces or surfaces. Each surface is made from a whole collection of edges, and each edge is created from a whole series of dots. Okay? That top row over in our modeling toolkit, this right here, allows us to transition between the selection of each one of those component pieces. This icon allows us to select an object. Okay? Let's just do it real fast. I'm in the object selection mode. I know I'm in the object selection mode because the background color of that tool is blue. So if I was to simply left click on my teapot, notice that its wireframe color goes green. Haha! This is the Maya indication that you have in fact selected this object. Now with this object selected, we can start to manipulate it. We can start to do a whole series of things, and I'm going to travel over to the left-hand side of my interface where I have these lovely tools. This is the Move tool. Yeah.
Can you zoom out a little bit?
Sure.
So you can see that right side of your. Because I don't have I don't have those 5 multi-component.
These in here? Do you have the modeling toolkit button
I
pressed?
see it. There it is.
Yeah, great.
Thank you.
Yep. So on the left-hand side of my interface, we have the Move tool. This is Move, Rotate, and Scale. With my teapot selected, check it out. Okay, I got it selected. If I fire off the Move tool, which is this one right here, I'm going to get some tool handles. Okay, see those tool handles? Just chilling inside of my three-dimensional scene. Now I can begin to move this object along the x-axis, the z if I'd like, or up and down on the y. Okay. Same with the rotation tool. The E key is the keyboard shortcut for rotation. Has anyone stumbled upon the keyboard shortcut for the Move tool? The W key, you got it. W is move, E is rotate. Take a guess, look down at your keyboard. What's the scale tool? R, like a pirate.
Which doesn't make sense because why would R be the
Right. So W, E, and R. These are very industry standard keyboard shortcuts. You go into any 3D modeling app, W, E, and R are move, rotate, and scale. Blender's a unique beast. Blender's off the grid. Okay, when it comes to a lot of these conventions, they're doing what they want to do. Anyways, point being is that we can select something and then we can begin to manipulate it. I have the rotation tool going, and now I can start rotating my object around inside of our three-dimensional space. Okay? Or I can fire off the scale tool and flatten this thing like a pancake if I want. Okay? And at object mode, I'm manipulating and transforming the entire teapot. But what if I want to go in and just manipulate maybe like the handle, or make the spout a little bit longer, or rotate the spout a little bit differently? I now need to start selecting components of the overall object, parts and pieces of the overall shape. If you think of it like this, right now we are moving the entire car, but what if I want to go in and just move and rotate the engine? Or like open the door, or just like monkey around with the steering wheel. Okay, a car is really nothing more than a whole series of components bolted and welded together, and the combination of all of these pieces create a car. 3D models, not that different, in all honesty, right? So in order for us to go in and start selecting all the component pieces, once again we're going to return to our modeling toolkit. This allows me to select the object. This is my vertex selection state, edges, then faces. Okay? The tooltips are really helpful. F8 gets you into the object selection mode. F9 is verts, F10, and F11. Okay? I'm going to go into my faces selection mode real fast and check it out. There's some good stuff in here. Now, instead of being able to select the entire teapot, check it out. I can go in and I can just I'm holding down the shift key, by the way. and I can add polygons together inside of a selection. With the scale tool still on, now I can go in and scale just those one pieces, or maybe move them out and create a really weird shelf thingamajig on the side of my teapot. So instead of managing and working with the entire piece, now I'm working with individual component pieces of that shape. Okay?
My teapot, when I select the faces and drag, it's not giving me that kind of control. It's like
Yeah. So let's talk. You got it. So the folks that have some experience in other 3D apps, specifically Modo, have the hardest job in front of them because we get to fundamentally rewire your brain. The selection engine in Modo is wholesale different than the selection engine that we have here in Maya. So we can't just like left click and drag on an object and select the stuff that's underneath our cursor initially. So let's actually dig in to some of the selection features. Maya works around this really cool selection engine of just simply left clicking on something. Whatever we left click on, it's going to select it. But what if I wanted to select a whole big chunk? Like that. A whole big range of things. It is darn near impossible to see because it's very, very faint. But if you were to left click and drag, you get a selection box. Okay? Now, whatever's inside that box is going to get selected. See how those polygons were inside that box? And they selected. Okay? So if I wanted to grab a big chunk here in the center, I left click and drag, and I get to select all those pieces. Okay. Now, one of the challenges that we have, and some of you guys are probably getting something that looks like this. You select with the big marquee selection box, but then it also selected all the stuff in the back too. Are you guys getting that? Some of you guys are getting that? This is an important setting because you go over into the design lab, it might look like this. Okay. Maya, this is the big problem that we have here on any campus, and it's not just ours, is that it's kind of like the Wild Wild West, okay? You never know who has been using Maya before you, and you never really know how they've changed it or what they've changed, right? The selection engine is something that can be altered. What I've done here, and I'll just do it again so everyone's on the same page, and I think let's just do it very, very simply. I'm going to left click and drag a box on the inside of my teapot. I know it's hard to see. And on the surface, it looks like I've just selected the polygons that are on the front side of the teapot, right? But if I held on the Option key and left mouse button and dragged around to the back, oh yeah, that's no bueno, right? I've now selected the front side and the back side at the exact same time, okay? Now, at times, this is cool, right? Because it allows us to very quickly select entire groups of things. For example, if I wanted to grab everything under, inside this box, bloop, I now know that I've selected the entirety of that shape very quickly. Some people like it, okay? Some people don't. The setting that changes this is over here in our modeling toolkit. And it's the camera-based selection setting, this. Right now, it's off. And so we're doing what's called a select through. We're selecting through the box and anything that's, that's like a laser beam going all the way through our model.
I was noticing, does it depend on what your view is?
Absolutely.
Mine was going down.
Down, absolutely, yep. Yeah, it's as if you're firing out a big laser beam from your eyeballs, and whatever hits that laser beam is going to get selected. Okay, so if you were to turn camera-based selection on, so if you return to the modeling toolkit, hit the little drop-down arrow, boom, right there, okay? Now check it out. Our selection behavior changes. Once again, same thing. I'm going to left-click and drag out a selection box on the inside of my teapot, and I grab just the polygons that are facing the front. This time, if I was to orbit around the back, nothing's been selected. Okay? Nothing's being selected. Yes, sir? I have no idea. I really don't know. Yeah. I always get really afraid when something says auto. What is it doing? I don't know.
How do you loop select in this?
You can do it.
It doesn't work that.
Yeah, the selection engine is different. I would encourage you, I'm not going to go off on it at the moment. Edges are simple. You just double click on an edge and we'll loop select. For polygons, check out the select pull down menu. There's a lot of good stuff in there. And specifically, grow along loop. I mean, check it out. There's some good stuff in there. Okay? All right. Let's keep cruising here. So the camera-based selection, that's something personally that I usually just keep on. Okay? I'm going to go back to my, my faces selection set. Okay? And here's a great trick, because I like to be able to very quickly go in and kind of create a very custom pattern of components that I've selected inside the shape itself. Here's a great, this is Pat's power user trick of the day. Okay? We have inside of Maya a paint selection system where we can left click and drag on the surface of something, and wherever our cursor kind of ends up, that's what's going to get selected. It's pretty neat. Okay? It's an invisible feature, and this kind of speaks to the part of Maya that I really don't like. Sometimes they bury features. It's like a special little club. It's like those really cool bars that don't have signs on the outside. You're just kind of supposed to either expect to know where they are or stumble upon them, right? Maya is full of those. Okay? Check this out. I'm in my faces selection state. If I hold down the tab key and then left click and drag on my mesh, wherever my cursor goes, I'm going to add those polygons or components to my selection, which is pretty cool. So it's the tab key. And then if I cursor over them, I can subtract them very quickly. So that's pretty cool, because I like to just be able to go in. I come from, I work with styluses a lot, so I like to be able to draw and paint on my models very quickly, so that's a pretty nice system for me to use.
Like if you hold tab, do you add and subtract at the same time, or once you start adding, you only add?
Yeah, so if it's already selected, like I have here, okay, I'm holding down tab. If it's unselected, it will be added to the existing selection. If it's already selected, see how it subtracts it?
Yeah.
Yeah.
I mean, if you hold tab on selected and then mouse over unselected, does it make it selected?
Yes.
Subtracting and adding at the same time?
No, yeah, you can't add and subtract at the same time. So if you hold down tab and you click on something that's unselected, it selects it.
Okay, yeah.
Yeah.
I know, I got the answer.
Cool. All right. So the tab key, that's a good one to commit to memory. In addition, if we look at our teapot, it's really comprised of 3 separate pieces. We have the spout, the body, and the handle. Okay? We could, these are called discontiguous polygon islands. Okay? Like pieces. Try double clicking on your spout. See what you get. What's it do? Yeah, it selects the entire spout. All of those polygons are welded together in one piece, if you will. Check it out. This model is actually made up of 3 separate pieces. It looks like one teapot, but if I select the spout, hit the W key to fire off the move tool, and move it out of the way, that's what it looks like. Same thing with the handle. I'm going to double click on the handle polygons. Can move them out of the way. And you can see pretty quickly the illusion that is 3D modeling. Okay?
On my machine, it's dragging the entire model.
Okay, let's see what we got.
So, basically,
Okay. Rob has hit the B key on accident, which is a common mistake. Happens, not his fault. The B key turns on a system that looks like this. So if you see a whole bunch of rainbow colors on your screen, you have enabled what's called soft selection. And the keyboard shortcut is unfortunately placed right above the space bar, the B key, B as in boy. Okay? Hit the B key again, it turns it off, you should be on your way. We will talk more about the soft selection system in the future. It is awesome and you will like it. It's pretty great.
So I have a question about like camera rotation. Because I know in Moto there's a weird camera option that like you said worked really well if you had a trackball as opposed to an actual mouse.
We don't have that option.
Yeah, but there's,
Not that I'm aware of, at least.
is there any way to like, because I wanted to, if I zoom in, if I start to pan, my rotation starts becoming more of a camera as opposed to rotating around the object.
Yeah. Yeah.
Is there any way to disable that, or
Not really.
you just
And
have to pan and rotate and just try and figure it out?
this is, well, here's really the solution to that problem. And I'm not sure if I'm going to be able to reproduce it here with my teapot because I'm already in pretty close, but that happened to me on the previous example with the arrows, the big arrows, where I tried to zoom in, and I got to a point where I really wasn't zooming in all that much, and the amount of rotation or orbit inside the viewport was very, very small. The way to solve that is to make a selection, hit the F key. It's going to recenter the orbit and the tumble to the selected component.
Well, I mean, like, if I wanted to, let's say I wanted to look inside the spout. What I would normally do is, like, I would pan over to, like, the spout, zoom in on the top of it, and then rotate up. And for some reason, like, it doesn't. Now, okay, this one's going fine now, but earlier it was rotating weirdly, where I couldn't actually just look up and kind of curve around it. Even
Yeah.
It would, like, put it at the top of my screen instead of in the center.
I understand. You know, that may be in there. I'm not sure off the top of my head. Yeah. All right. Alrighty, right. Let's keep cruising here because a couple other things I need to talk about before we go away. Okay, and before we start working. Okay. So everyone kind of feeling the selection engine to a certain degree? Yeah. Get some practice with it. I mean, one of the things that I honestly try to recommend for folks that are first starting off is just to go home and just to kind of monkey around with things and get used to working with the selection engine. Because we're going to be selecting things every other moment in here, okay? It's not, do you have a question? Yeah.
On the computer at home, so you said this is locked after class. Where can I go after class?
I am so sorry. I forgot to mention this, and I think I got so excited about teaching you guys Maya, I forgot to talk about the design lab. The design lab is in T109. If you go right out this door, hang a left, it's kind of down towards the end of the building. It is a room that looks very similar to this. It's actually probably about 3 times the size, and that's an open lab where you get access to it basically 6 days a week, sun up to sundown. And that's where you can, as long as the campus is open, the design lab is open. The hours are on the outside of the door. I think it's 8 to 9, Monday through Fridays. Monday through Thursday, and then 10 to 5 on Fridays, 10 to 5 on Fridays, and then 10 to 5 on Saturdays too, right? Yeah. So it's open more than it's not. So that'd be the place to go and continue working on this stuff. I apologize for glossing over that earlier.
How many hours do we have to log a week?
90 minutes.
90 minutes.
Yeah.
Is there a way to
Every week?
Every week. Yep.
I thought I should point out that if you hold right click and then move your mouse,
We're not gonna get into that at the moment.
you can change how you select.
Absolutely. It's called the marking menu. We'll come to that in a minute. Yeah. Yep. Okay. All right. Other questions on the selection engine inside of Maya?
Figured out the A is centering on the entire, like,
The entire scene.
yes, scene, whereas F is on your selected object.
Awesome.
Yeah. Figured you might want to know that. I'm sure somebody else had that question at one point.
Thank you. Other questions on selections? Okay, cool. All right. So here's what we're going to do now. We're going to say goodbye to our teapot. And we're going to create a new scene file, okay? Because, you know, messing with someone else's model, that's cool, but we're going to be making our own models in here, okay? So let's make a new scene. Goodbye, little teapot. And now we just have an empty installation, okay? Hint, hint, nudge, nudge. I'm about to do half of your lab assignment for you. Hint, hint, nudge, nudge. Yeah. That's fine. Yep. Yeah.
That's fine.
Yeah, no, you're there. You're there. Okay. So your lab assignment this week is to create a whole series of unit primitives and start to line them up in a way that gives us the ability to take a picture. Okay. So one of the cool things about the Maya interface and this Maya as an application is that we have access to a bunch of toys. Okay. We don't have like a couple tools, right? We have hundreds of tools inside of Maya. Okay. It's a deep app. Okay. I'm wholesale jealous of my colleagues in the graphic design industry because they can master maybe 8 or 9 tools and poof, they're done. That's not our world, right? We have hundreds of tools. Let me show you what I'm talking about, okay? At the top of the screen, one of the cool things about Maya is that the developers have organized some of the tools into shelves, these tabs, okay? So all of these things in here are called shelves, and they're a collection of some of the tools. These are like the favorite tools, the all-star tools, if you will, okay, that surround a specific workflow, and there are a bunch. Some of these, I have no idea what they do or how to work, okay? There are portions, admittedly, of Maya that I have never actually entered into. It's that deep of an app, okay? This is a full spectrum application. It does everything, you know, soup to nuts, okay? It's deep. There's a lot of stuff in here, okay? So for the most part, we're going to be hanging out in the poly modeling tab for the most part. That's where we're going to be doing most of our work, okay? I bring this to your attention because its neighbor to the left visually can be a little bit confusing, right? Because if you look at the curves and surfaces, you're like, oh, cool, squares. Over here, you're like, oh, cool, this is how we build a sphere, right? And then you click on this sphere, and you go, cool, I'm going to select the polygons on this sphere, and you go, this is different now. What? I can't, there's no move tool. Okay, well, this is not working, Pat. You said this was going to work, right? Poly modeling. What we've entered into here is a special surface type that's unique, that doesn't exist anywhere else other than Maya, and it's called NURBS. Yes, you heard me say that correctly, NURBS, okay? And just so everyone's on the same page as to what in the hell I'm saying, okay? This is something that's a Maya specialty. NURB. This is so geeky. I even feel geeky saying this. Okay? NURBS. Did not make this up, by the way. Okay? It's an acronym for non-uniform rational B-spline. Okay? If I know that we have some folks in here that are familiar with like a traditional graphic design pipeline. If you were to go over to Photoshop, okay, what type of artwork primarily in an image editing environment are you going to be creating? 2D and like photographs, right? On a technical level, how would you describe a two-dimensional photograph? What is it made out of? Pixels, right? It's a bitmap. It's a whole collection. It's a grid of pixels stacked on top of each other, right? The inverse of that over in Illustrator is what type of image? A vector image. Now, how is a vector image created? Points and paths, right? And the cool thing about vector imagery is that it's resolution independent. We can make it any size that we want, and it's always, always, always going to look pixel perfect, right? You're never going to see a jagged edge on a vector image, right? The NURBS surface, if you will, is our vector image, okay? It's not made up of polygons, okay? There are no faceted faces on a NURB surface. It's a mathematical understanding of a shape, okay? They are cool, they are awesome, but they are probably the most difficult thing to create and manage inside of Maya, right? And they only exist inside of Maya, okay? They're pretty neat. If you're doing like a car, okay, you're gonna make it out of a NURB surface, right? That way you don't see a single polygon on that smooth sheet metal, right? If you need something to look incredibly, consistent and smooth and just absolutely perfect, you want to make it a NURB surface. We are not going to be looking at NURB surfaces at all in this class because they are incredibly difficult to create, manage, and edit, right? And you don't see NURB surfaces outside of Maya. You don't see NURB surfaces in a game engine pipeline. Everything outside of Maya is polygonally based, which is why we're going to focus on the poly modeling tools in here. Okay? So, poly modeling shelf, that's where we're doing all of our work. Okay? Undo, get rid of that. Okay. One other, this is a big, big pitfall. You have a question?
Is there a class where you do focus on?
A little bit in 410, GCOM 410. Okay. Yeah, which is our advanced computer animation class. We'll talk a little bit about NURBS, just a little bit. They do have a role. If you're staying in Maya, so if you're doing all of your modeling, all of your rigging, all of your texturing, animation, and rendering in Maya, NURBS has a role. If you're not, It doesn't have a role because it's only a Maya thing. Okay, the other major pitfall when it comes to working inside the interface, and this is going to be a problem for you, and in every sense it kind of speaks to the depth of the application, believe it or not, are all of these pull-down menus at the top of the screen, okay? There are a bunch of them, and each one of them seems to have almost a never-ending list of tools and commands and options, okay? They're even unintelligently laid out, like my poor little brain cannot manage, and I've been doing this for years, the difference between the mesh, edit mesh, mesh tools, and mesh display. I mean, that's all the same thing for my little pea brain, okay? And I have 4 of these things I now got to memorize. It's just drives me crazy. Anyways, why these menus are going to be a problem is that, or specifically, is this, oops, got it here, is this pull-down menu right here. If you're following along, got mine in front of you, change this, doesn't matter what, and watch what happens. I'm in the modeling section. If you were to left click on it, it's a list. Go to FX. What happens? Yeah, all the top-down menus change. Okay, so check it out. Here's the modeling, mesh, edit mesh, mesh tools. Those are all up. And then look, now we have rigging menus, animation menus, FX menus. This is deep, y'all. Okay, it's pretty big. Be mindful of this as we start to go out of this room. You go over into the design lab or at home, the person that was sitting in front of you could have changed the menu. I've gotten people saying, where are all my mesh tools? And I go, just make sure you're in the mesh pull-down menu selector.
What does the N stand for like N particles and class?
If you were to take an algebra class, what does N mean? Number. Kinda variable. Right, variable. That's where it gets its surface, or its roots, is this idea that it's a, you input a whole series of variables, and a simulated kind of event, happens. The N cloth, the N particles, the N fluids, these are all dynamically driven, almost kind of algorithmically based thingamajigs. They're pretty cool. All right, so be mindful of this, okay? This is going to be a thing for us. Now yeah, thank you. Yeah, go ahead.
I know I've seen a YouTube video for this, but I just wanted to clarify with you how to like save your settings on your desk and then just put that on a flash drive and then you go to the new, like say you go to the lab.
Yeah.
You just plug it in, you click that, and then it just like creates
Yeah.
everything.
I'm going to save that conversation for a later time.
Okay.
On day one, I don't want to overwhelm people. Right. Okay. That is absolutely a functionality of it, and I think that's cool. In that same conversation, there's a way to master, kind of reset Maya, and that's something that I want to talk about in the not too distant future, but I'm not sure if today is that moment. So we'll come back to that idea. All right. So for our lab assignment this week, we want to create some geometry, and we want to get used to creating this geometry. And the poly modeling shelf is really our home to create a whole series of what are called unit primitives. Okay. So if I wanted to create a cube, excuse me, check it out. Just click on that button. Pop quiz. Where was this cube created? At the origin. Okay. The origin is going to be the central point for every operation inside of Maya, right? Every time we create a locator, a box, a rigged element is going to be placed at the origin of our scene. The center point of our universe has a function, okay? So I've just created a cube, which is awesome. That's pretty neat. Now, once again, I'm going to return to my poly modeling shelf and click on the little sphere icon. Okay? Blah, but where's my cube? It's inside my sphere. When something's inside another object, how can I select it? It's a good question, right? So we can hide the sphere. How else could we select the cube? What was it, Gabriel? The outliner. Okay. Another way is to move the sphere, which will expose the cube. But I want to talk about the outliner real fast, because this is the last bit of interface that's really critical for us to move forward over the next 7 days. Okay? The outliner is currently not on the screen. Okay? The outliner can be found by going to the top of the screen, and it's under the Windows pull-down menu. And it's in the middle, down here at the bottom. Or kind of in the middle, excuse me, the outliner. The outliner, now for me it's being put over here on the left side or the right side of my screen. Sometimes it gets placed on the left side of the screen. Sometimes, but depending on who's used Maya before you, it gets placed in a floating palette. It's going to show up in one place or another inside of your interface. But what are you seeing inside the outliner here? Yeah, it's a list of all the objects that are currently active inside of our three-dimensional scene. Okay? If you're coming from Modo, this is the list, the item list. Okay? So we can see pretty quickly all the active participants of my little three-dimensional universe right now. Where do we go to get the outliner? So we're going to go to Windows, Outliner. Okay, so with the outliner open, you can see all the active participants that are just kind of chilling in our three-dimensional scene. This is an excellent way for us to very quickly go in and select some stuff, okay? Because now I can just simply select the cube from the list. Bloop, okay? The outliner is going to override any sort of selection that I currently have in my 3D viewport. So I know that if I was to simply fire off the move tool, that I would in fact be moving the cube. Okay? So the outliner is a great way to see all the participants of our three-dimensional scene and continue to work with them and edit them and manage them in a big sense. This is going to be a central kind of utility palette going forward for us, the outliner. So get used to going to it, remember where it is, and come back to it over and over and over again. On day one here, we only have, a couple items, but on day last, on May 22nd, when I think we're right around there when the semester ends, you're going to have 3D scene files with maybe 100 or 200 different objects in them. Okay, our scenes are going to get dense. There's going to be a lot of objects in them, so being able to manage them in a list view is important. Okay. Okay. So the outliner is going to be important for us. Now, the last bit of this that we're going to talk about today is rendering. Okay, is rendering, because we have some things that we've created. Good job. Pat myself on the back. I made a sphere and a cube. Give me the Academy Award right now. I'm the best 3D modeler on the planet. But I need to get this out. Maybe I want to share my victories with my friends on Facebook and put this on Instagram. Hashtag Professor Pat Rocks. Joking. You don't have to do that. You should do it. No, you don't have to do it. So we need to draw the picture, and this is called rendering for us. Okay, and this is really where the computer takes over and is physically responsible for drawing a picture for us. Okay. Now inside of Maya, we have some really great rendering technology that can be found up here at the top of our screen. That's these buttons. Start to expose our rendering engine. Okay. This button, this first one opens up the render window, the eyeball. But really, to create a picture, we click on this one, the second one. It's the render current frame icon. It's the little clapboard, the slate, as it's referred to out there in the film world. So if we click on the slate, the render engine is going to take over, and voila! You either see something, or for some of you guys, it's going to look like this. You either see this, or something looks similar to this, or you see blackness like this. Okay? Let's talk about this for a second. Okay? I mentioned before that as 3D modelers, we have to wear a lot of hats. And we are taking off our 3D modeler construction hat, and now we're putting on our photographer's hat. If we were to go over to the photography classrooms on campus and into their studios, of course there's going to be digital cameras, okay? But there's also going to be what inside their studio? Lights, okay? We need to put some lights in our scene, okay? We're going to get complete blackness without some sort of light. Now, if you rendered your frame and you saw blackness, you're already using the most powerful rendering technology in the app, which is called the Arnold renderer. If you had a picture that looked, so I'm going back to Maya software, if you have a picture that looks something not too dissimilar to this, you're using Maya software, and we want to walk as fast as we can away from Maya software because it is a gigantic steaming pile of garbage, right? I'm wholesale convinced that the developers down at Autodesk gave up on their own rendering engine because other people did it a whole lot better. So we want to use the best technology that's available for us to create some really compelling pictures. So we're going to be rendering all of our images not in the Maya software rendering engine, but in the Arnold renderer, okay? Which is it's a plugin for the app that has some really great computer science that creates a physically based image, and it's great, okay? However, the moment we start rendering things, again, I'll hit the little slate, using the Arnold rendering engine, we draw focus to the idea that our entire little universe here is black. It's empty, okay? We need to put some lights into our scene, okay? Let's just do it real fast. I'm going to close my render window and go into our shelves, okay? Polymodeling, if we keep marching down our shelves here, we're going to find a shelf eventually called Arnold. Check it out. This first icon in the shelf allows us to insert an area light, okay? For those of you that have already clicked on the button, where is this area light placed in the scene? The origin. And you can see its icon inside of our three-dimensional scene. With it selected, I'm going to hit the W key to move it out of the way and place it kind of in front over here. What do you think this line coming out the front of this little square represents? Yeah, this is the direction the light is facing inside of our three-dimensional scene. So pay attention to that little line coming out. And let's take a picture. Hit the little slate, and then voila! You can see that now we're getting some illumination in here, right? If yours is still very, very dark like mine is, I mean, you can barely see that, okay? There's one small change that we need to make. Is my light selected right now? Yes. How do I know that? It's green, right? Since that light is selected, oh no, we get a crash. Sorry. Maya crashes, okay? Just hit don't send on that popover or exit it, yeah, and it will continue the crash. Since that light is selected, we now can go into the attribute editor, which is right here inside the interface. If you don't have a little tab underneath your modeling toolkit that says attribute editor, as I do here, it's this button, okay? This is the modeling toolkit, this is the human IK toolkit, this is the attribute editor, okay? And the attribute editor is going to expose all the properties for this selected object, okay? Because there are, at times, you know, they could be hundreds of separate small little tweak properties that will change the behavior of whatever it is that we have selected. I have my light selected, and if you look closely, the tab here says AI, area light, shape 1, and then I got a whole bunch of properties down here that I can change, one of which is intensity, which is just a very fancy word for brightness. My light's pretty dark, so I'm going to increase that value, okay? I want to put it to like 50. There we go. And hit the enter key. And now, let's make another picture. Oh, look at that. Maybe a little too bright now. Okay? Once again, I'm not even going to close my render window. I'm just going to go back to my attribute editor. If it was too bright at 50, but you know, very, very dark at 1, where should I go? And I really don't know the answer to this question, but let's just play around with it. Let's just see what 25 gets us, okay? Just enter 25 into the intensity, hit return, make another picture. That's better, okay? Congratulations, you've just now made your first piece of 3D imagery. And that's it. You know, this is basically what they do for Star Wars. I'm kidding. It's a little bit more complex than that, but I guess fundamentally this is what they're doing. They make models, they put lights, they take pictures, boom, Star Wars, right? has anyone discovered how to save our picture? There it is, right? This picture still and will only exist inside of Maya until we save it. File, save image. Okay? For every assignment, and I mean every assignment, you're going to be submitting a render, okay, a picture, and your Maya project file, the .mb. Okay? So when we do file, save image, we've now completed 50% of each assignment that we do in here. And I'm just going to save it all on the desktop. We'll call this test or test. Okay? I'll save it. If I hide Maya, there we go. Oh, I saved it in the wrong format. Okay, save image. This is my problem. I forgot to change the type from alias pics to JPEG. I'm going fast here at the end of the day. There he is. Okay, and now that JPEG is just a JPEG like any other picture that's on our computer. Okay.
So one thing that I noticed when you go to save the pictures, there's a setting for raw image or with another setting. You don't want it to be on raw image, otherwise if you screw with the exposure, it just won't.
Yeah, it's no longer a color managed image. Yeah, it bakes in the color profile. We're going to come back to that for week 1. I just want you guys to make a picture. If the colors are all messed up, don't freak out. We'll get there. So when it comes time to submit both your homework and your lab, let's go back in and save this. So File, Save Scene As. Again, let's just call this Test. Yeah, I got open Windows, which is why it's popping back up. There we go. All right. So when it comes time to completing your lab assignment, this is it. Those are the 2 things that you're going to submit to the Dropbox on Canvas. Okay? You're going to name them differently, but you're always going to submit your Maya project file, the .mb, and then a JPEG or a render of the scene that you've created. Okay? You have 2 missions in front of you this week for your homework in your lab. Okay? If we return to Canvas real fast, we can explore exactly what I'm asking you to do. These will go pretty easy. Pretty simple. Okay, so start with the lab. This is a real easy one. You guys are going to have a couple minutes here at the end of the class today to do this. Okay. Your job in the lab is to create 3D models of a cube, sphere, cylinder, cone, and torus, which is a fancy word for donut. Okay. Where inside the Maya interface can we go to create these unit primitives? These primitive shapes. Yeah, that poly shelf, right? Just create them, line them up, put them all in the scene. Make a picture that showcases all 5 of them just chilling in your scene. Make a render. Submit both your finished project file and the render to back here to the Dropbox on D2L, and we are good to go. This is a procedure kind of project, right? Same with our homework tonight. It's just to kind of get us up and running with the app. These are the 2 most uncreative assignments that we'll do all semester long. And these are the only 2 uncreative assignments that we're going to do all semester long. So trust me, it gets better. So when you're done, make sure that you're following as closely as you can this naming convention. Okay? This is really for me and for you. You're going to be generating, if you take a step back and think of this, you're going to be generating at least 4 digital project files a week, because every week there's always going to be a lab assignment and there's always going to be a homework assignment. You need to stay organized, right? Because you're going to be generating a ton of content, right? The naming conventions are going to help you keep, keep on top of this and stay organized. This also helps me grade and manage all of your project files a little bit more efficiently. You have 4 things that you're managing every week. I have 100 things that I'm managing every single week. And that's just for 1 class, and I teach 5 classes, so I have about 500 bits of data that I'm managing every single week. So this really helps me grade your projects and manage your projects as efficiently that we all want us to do it. Okay? So follow these naming conventions. Clearly, you're going to replace last name with your last name, and I wouldn't be bringing this to someone's attention or our attention if someone hadn't done this before, where they just copy and pasted the naming convention, they put it in their file name, and they didn't. This went on for a couple of weeks, where they didn't realize that they were forgetting to replace last name with their last name. It was, anyways, yeah.
Do we replace unit with anything?
No, unit primitive. That's the name of the lab assignment, unit primitive. Yeah, so if you follow the naming convention, there is actually a method to the madness. Out there in the production world, we want to start with the most general descriptor and the most general identifier of this file as we can. Because out there in the real world, you're not working on the Macintosh or Windows operating system. You're working off of a Linux or a Unix server. And everything in those environments is command line driven. So when you go to open up a file, all you see in a folder is a list of different files. It's not like a fancy GUI system. It's all command line driven, right? So in a command line driven environment, the way we organize things without having a whole series of nested folders is to give each file context, right? The context is usually defined in the convention that we use, okay? The most general identifier of this file is your last name, right? And then after each underscore, we get a little bit more specific, right? We get a little bit more unique. So that at the end of the name, this file is so unique and its context is so understood that it makes it separate and different from any other file on the server, right? So we get a little bit more specific. This is Pat's, Crandley underscore. Well, this is a GCOM. This belongs to Pat, but it's actually, it's part of a GCOM class. Well, which class? GCOM 402. Is it a homework or a lab assignment? Oh, it's a lab assignment. Which lab assignment? It's a unit primitive lab, okay? We've gone from very general to very specific in the file name. This is a great way of working. Yeah?
Do that in the graphic design world too. Like, could that work? That's how we.
Yep. Yeah. Yeah. This is used all over the place. Yeah. When I worked at MTV, I didn't tell you guys that. I worked at MTV for a couple years doing a television show. It was a computer animated television show called Video Mods, and we made real music videos with video game characters. And this is about 2000, 2001. And I was the post-production supervisor and 3D art lead, so I managed a crew of about 20 guys and gals as we did about 2 hours of computer animation. And one of my responsibility was managing all the data that was flowing through our production pipeline. And I became the naming convention Nazi, right? Because I got really specific on how things were going to be named and where they were going to be placed on our server. And I printed out this almost floor-to-ceiling chart of all the different folders, right? And all the different folder and file names. And when someone was ever confused as to what they were supposed to name their file and where they were supposed to place it, I would bring them over to the chart and says, this is where this file needs to go, because Matt over there, once something's in that folder, Matt's going to grab it and he's going to work on it, and then when Matt's done with it, it's going to go down here, and Samson's going to go, start working on it too. So there's a flow of how all these parts kind of work together, and the naming of our files are very important. Yeah, because if you can't, it's like a tool. Tools that are placed in drawers don't exist, right? Tools that are, files that are named incorrectly don't exist. Okay, so how we name things is really important. Okay, so that's for your unit primitive lab. You guys are, if not done, almost done with this. Okay, the other thing that we have to do this week is our homework. The homework is a little puzzle. It's a shape sorter. Okay, I've given you the project file for this little puzzle. It's down here in the resources section. Let's just take a look at it. All right, so here's the puzzle. Your job is to move, rotate, and scale all the yellow pieces on the right-hand side of the screen into their respective spots in the big blue frame. Okay? I'm not going to tell you how to do this. This is a puzzle. It's an easy puzzle. And if you really want the answer to the puzzle, look at the banner image on the homework assignment. Hint, hint, nudge, nudge. But after you're done with this allows us to kind of continue to practice selecting things and moving and rotating and scaling, and then most importantly, taking a picture, making a render of it. So at the conclusion of this small little puzzle, take a render. It can look like anything. This is a utility assignment, just kind of getting us to understand the system that we're working in. Okay? Just make a picture. It can really be composed any way you want it to compose. But please make sure you're inserting a light, as we did a second ago, and render using the Arnold renderer, like we did a moment ago as well. Sound good? Any comments or questions? Yes. Really? I did it that well? Yeah.
Quick question. In your syllabus, it mentions a recommended but not required book.
Yeah.
How much do you recommend a book?
If you're into this, I mean, if this is something that you're truly passionate on, it's a good book. I have it in my office, and I think Chris has it over in the design lab too. It's just a recommended book. It's kind of, it focuses more on the technique of 3D modeling than the actual application itself. So it's not like a Maya book or a Cinema 4D book.
Are we going to struggle at all with all the stuff that you're giving us if we don't have the book?
No.
Okay.
Yeah.
It's 402, not 424.
What does it say on there? It's supposed to say 402 on the naming conventions. I copied and pasted from my stuff yesterday. I will fix that in 10 seconds. Thank you for bringing that to my attention. Yesterday's 424 crew did. See, 424 yesterday and 402 today were kind of the same because everyone's learned Maya for the first time on our campus this semester. The guys and gals that are in 424 have taken 402, so I needed to get them up and running with kind of the basics of Maya, which is why it's kind of duplicated. Yeah, I mentioned to them yesterday, this is the only day that's going to be the same because the paths diverge in opposite directions starting next week for both the classes.
All right, one more question.
Yeah.
Primitives one, do those got to also be colored? Or
If you can get there, color them. I'm not going to go into that today, but if you want to explore how to put some color on that, do it, man. The cool thing about working inside of the Autodesk ecosystem is that YouTube is a video encyclopedia for every part of the application. I mean, it is fantastic. That's one of the things we struggled with when it came to working with the Foundry products, is that the support outside of academia was very little. It's not the case with Maya. I mean, shoot, during my lunch break today, I had a question. I was trying to figure out how to work with these nonlinear deformers inside of Maya, and I was trying to reorganize the deformer stack, and I could not figure it out on my own. And what did I do? I went onto YouTube, and I went nonlinear deformers in Maya, and poof, I got like 10 videos that told me exactly what I needed, okay? So go explore, go poke around. It really is of benefit, for sure. This is going to sound weird, and I'm sure a lot of you guys are not used to having professors and people like me say this in places like this. I am not going to teach you everything you need to know about Maya. Yeah, it's not going to happen. It's a representation of how deep this entire playground is, right? We have jumped into the Pacific Ocean of technology. It's deep, okay? So look, explore. There's a lot in there that you're going to be able to find online, for sure. Other questions, comments? All right, good luck. I'll see you guys next week.